Hello, everyone. Thank you for coming. The title of this talk is the JSR update. We're going to be talking about several different JSRs, Portlet 3, the new bridge spec, JSF 2.3, MVC 1.0, and Servlet 4. Again, my name is Griffin, and I'm the lead for the Liferay Faces project. And I'm also the spec lead for JSR 378, which is a brand new spec we're going to be talking about. But first, I'd like to introduce you to Scott Nicklous. Scott Nicklous is the spec lead for Portlet 3, and I know portlets are all near and dear to our hearts as developers. Scott joined IBM in 1984, and he's the manager responsible for Websphere for the Portlet container and for WSRP. And again, he's a spec lead, so thank you so much for coming today, Scott.
And thank you, Neil, for the invitation.
And we have a treat for you today. We're going to be showing off some features of Portlet 3 that have been implemented in Pluto, which is the reference implementation. The information that we're showing you today is really just information that you can get publicly on the internet. It's available from the Portlet spec, from the mailing list, and so on. It is not final information, but it is quite mature at this point. Before we begin, I wanted to talk briefly about the JCP, because each time I talk about the different JSRs and so on, I find that there are people who have never heard of the JCP before. The JCP is the Java community process, and it's a governance board. It's in place to move Java standards along. And you can visit it at jcp.org. Now, the thing that's great about the JCP is anybody can join. You can join as an individual, or you can join representing your company and participate on the different JSRs. A JSR is a Java Specification Request. And each JSR has a corresponding committee. A committee is made up of spec leads, one or more spec leads, and expert group members. The first JSR I'd like to discuss is Portlet 3. This is, of course, as I said, led by Scott, and he convened the expert group in March of 2013. Liferay and Vaadin and Oracle and other companies are members of the expert group. And please, I hope I'm not stealing your thunder here, pleased to inform here, I'll let you hold it.
Yeah. Thank you.
Pleased to inform you that the spec early draft review was submitted to the JCP yesterday. So that's very exciting, because we've been working on this since March 2013, and I certainly have to give credit to Scott and to IBM for putting so much hard work into this spec. And we hope to have the final done 2016, right?
Yeah, it's going to take another little bit.
Each one of these slides has a URL at the bottom for the JCP website page that you can visit for each individual spec. We do have a link here for where you can actually download this spec and give it a read. I actually imagine there are people here who would like to read this. We love comments. We would like to get your feedback. And we also need your help. A little bit more about that coming up. Some of the main features of Portlet 3 is we're going to be aligning with Java EE7. Now, portlets are a Java standard, but they are not officially part of the Java EE umbrella of technologies. However, it does have a dependency on Java EE, and specifically Servlet 3.1. So we've been looking at all the nice things that have been put into Servlet 3 and Servlet 3.1. And we're bringing some of those ideas into the Portlet API. There are some other nice things we're doing. We're trying to have some annotations that we're introducing in. So for example, you'll be able to declare a portlet with an annotation rather than using portlet.xml. We're going to be supporting file upload. There's going to be quite a bit of integration with CDI. You'll be able to create portlets without extending generic portlet. You'll just be able to have a plain old Java object and annotate a method. So we're all familiar with a method like doView, which is a method we would override in order to render markup for the view mode of our portlets. Well, with this feature, you'll just be able to have a POJO and annotate a method with an annotation called @render method. And the portlet container would automatically invoke that for your portlet. We'll also, but because of the CDI integration, we'll be supporting injection of different artifacts into these new types of portlets. The portlet state has become more explicit. So the portlet API has always had an idea of state, which consists of the portlet mode, the window state, and the public render parameters. Those three things together are what we refer to as portlet state. And this was always there in the portlet API in Portlet 2, but it was kind of implied. And so now the API has a much, much more explicit section in there for what we call portlet state. And finally, another big ticket feature we have is what we call the Portlet Hub. This is a JavaScript module that is now, so we now have some client-side requirements for portlet containers or for a portal to implement. And this is what Scott is going to be demonstrating for us today. So it's called the Portlet Hub, and he's going to show us how we can do inter-portlet communication and execute events and things like that with Ajax, which is something that we were not able to do with Portlet 2. So we're going to switch over to the browser. And let me see if I can go to Pluto.
I think it's better without.
And increase the size of the window a little bit. Is that helpful? And I'll let Scott take over.
Okay, thank you, Neil. First of all, I would like to thank Neil for his excellent support in the expert group. Neil has been with the expert group from the beginning, and he's made many contributions, and he was very patient with me at the beginning because I hadn't programmed portlets for a long time, and so there were many things that I needed to realize, and Neil was very patient with me and helped me get up to speed. So I really appreciate that, and I'd like to thank you. Okay, so now about the Pluto reference implementation. The reference, well, let's say the JSR process calls for a paper specification, and that's this document that we showed you previously, plus a reference implementation that proves that the specification can be implemented, along with a technology compliance kit, a TCK, which is a set of test cases that proves that an implementation behaves properly. So, and the reference implementation and the TCK for the portlet specification are both open source, and they're hosted on the Apache Pluto project. So we've already implemented a portion of the new specification. In particular, we've implemented the client-side API. The new specification will have a JavaScript API that allows the developer to execute portlet actions, change render parameters, create URLs, and that sort of thing, while remaining in an Ajax mode. In other words, without causing a full page refresh. And I can demo that now. So I need to set this up. Okay, and oh man, my eyes aren't what they used to be. So, okay, there we are. So this is our page, and there are 5 portlets on the page. And this one portlet has a counter that's implemented in JavaScript, and it just constantly counts. And it's reset every time the page is refreshed. So you can see that as long as the counter counts forward, the page is not being refreshed. So in the image selector, we can set a private render parameter. And by doing that, the portlet accesses through a resource request the markup for a different type of selection mechanism. And you can see that this was done without a page refresh, as would have been the case previously. I can also set a public render parameter. And you can see that both the portlet initiating the render parameter change and the portlet over here that also uses the public render parameter are both updated. The client-side JavaScript mechanism allows the JavaScript representing the portlet to be notified when a parameter change occurs or when some other type of event occurs. We have another portlet. First of all, we have okay. We'll just change the color. Okay, that worked. That's actually another public render parameter. The public render parameter is consumed by two other portlets, and you can immediately see that there was a graphic change, and you can also see that there was no page refresh. Now for the next portion of the demo, we have, this is an actual action. So a portlet is actually carrying out an action. The action request is sent to the portal, sent to the server, where it's executed. This particular action causes an event to be fired, which changes the state in a separate portlet. So I'll write in a message. And I can select a font color. And I can send it. Okay, and when I do so, the action is actually executed. This causes event processing on the server, and the markup for both portlets is loaded back into the screen and onto the display. And what happens is the message box portlet gets notified that a parameter has changed. And the results of this event are then retrieved by the portlet and displayed. So basically, you can see that that this JavaScript API allows portlets to update their state in AJAX mode. Just for contrast, we can switch to the older version. These are actually the same portlets, but written with the JSR 286 standard that does not have this type of AJAX update. You can see that we can change the display, and we can select a different image. But in this case, you can see that there's a page refresh, and the counter starts over again at 0. Okay, so that's the difference. In the one case, we have an AJAX style update, and in the other case, we don't. So, okay, and I think that's the end of the demo. I'd like to turn it over to Neil again.
Okay, I'd like to head back just to this slide right here, and I'd like to let you all know that when you look at this spec document, it's really quite readable. And let me search look for something like at Portlet Configuration. It's right here. All right, here. Yeah. So at Portlet Configuration is it's a new annotation, as I said before, that's going to allow you to be able to declare the existence of a portlet within your application simply with an annotation. And so I would commend this document and the reading of this document to you again so that we could get feedback. But also, I'd like to know if any of you would be able to help. The way we can get Portlet 3 done faster The way we can get it done sooner is if we have help. There are two ways that you all, well, really three ways you can help. One would be to review this document and the associated Java doc API and the JS doc, really, and get your feedback. Another would be volunteers who could help with the reference implementation with Apache Pluto. That would be taking the requirements from this document and implementing them within Apache Pluto. The third would be creating tests that are in the new TCK. The TCK is really quite comprehensive. The Portlet 3 TCK we have is far, far, far more comprehensive and extensive than the one we had for Portlet 2. But since it is a brand new piece of software, we need people to help write tests. So again, these are three ways in which you could help. And so I would simply ask that any of you who have time, who are able to volunteer, would please do so.
That's probably what you want. Okay.
Okay, so we saw the demo, and if you'd like to download this demo, the URL that you see there is where you can go to download it. It's a zip that you can download. It's a Tomcat zip that has Pluto built into it and has this particular demo built into it. Also, with regard to Portlet 3, we have a new spec, which is JSR 378, and this one is being led by Liferay, and I'm representing the company as the Spec Lead. The expert group formation just began back in August, and will be closing in late October, perhaps early November, and the reference implementation will be Liferay Faces Bridge. And I'm going to talk more about the Git repositories for this. We actually have split it. We have two Git repositories for this standard. The master branch of the Liferay Faces Bridge API Git repository and the corresponding master branch of the Bridge Impl Git repository are where this reference implementation is going to be. And if you'd like to follow the progress of this new standard, you can follow at Faces Bridge Spec on Twitter. Because we're talking about the reference implementation for this new spec, which of course is for Portlet 3 and JSF 2.2, I'd like to introduce you to the Liferay Faces team. This is the team of developers at Liferay that's responsible. We have Juan Gonzalez, who's in Spain. I have myself, Vernon Singleton, Kyle Steeman, and Phil White, and we're all in Central Florida. And we work on the Liferay Faces project, on all aspects of it, and we will be responsible for implementing the standards aspect for Liferay Faces Bridge. I can't say enough about the Liferay Faces team and how talented they are and how dedicated they are. And we've also made a commitment to try and answer every single question in the forums. So if you use Liferay Faces or you have questions about JSF and portlets, please feel free to ask a question, and we'll try very hard to get back to you in the forums. Just a brief update on the Liferay Faces project. We introduced extensive support for Liferay Portal 6.2. It came back in August of this year, where we have an all-new component showcase. If you visit liferayfaces.org, see if I can get back to this tab right here, you'll see that there's a component showcase that demonstrates each and every of the new JSF components that we have developed on top of Alloy 2.0. And you can demo these things live. This itself is a JSF portlet, and this application is available live for you to use and to enjoy. Regarding Liferay 7, we've begun work on support for Liferay 7, and there's a few different things I'd like to discuss regarding Liferay 7 and JSF. The first is we want to provide you with the ability to deploy, your traditional WAR type of portlet, which is the way we've always been doing it, or as an OSGI bundle. The JSF OSGI bundles would need to have their dependencies zipped up inside of them. So it's very similar to the WAR concept. Really, a WAR file is just a zip, right? It's a jar file, except it has its dependencies found in the webinf lib. And so this is a very similar type of concept where you would have the JSF API, the implementation, and maybe a component suite like Prime Faces, Ice Faces, Rich Faces, or Liferay Faces Alloy. You would have that contained within the OSGI bundle. We do have one issue that we're still working on to try and make this work and to complete our testing to validate that this is going to work, but so far it's looking quite good. The roadmap is for Alloy. Alloy is still going to be present in Liferay 7, and so our component suite is being updated to use Bootstrap 3. We've been doing commits for that, and to take advantage of the new features that we do find in Alloy 3. So if you've developed applications with Liferay Faces Alloy for Liferay 6.2, then your migration path to go to Liferay 7 shouldn't be too difficult. We haven't run into too many difficulties so far with that. And that's one of the beauties of the abstraction of a framework like JSF, where you're not interacting directly with the JavaScript API found in a technology like Alloy. You're simply using the declarative programming model of JSF views, and you get all of the JavaScript manifested for you by the JSF renderers. I'd also like to talk about this new component suite that we're planning on developing. If any of you had a chance to visit Myra's talk yesterday about MetalJas, she showed off the features of MetalJas, but she also showed off some JavaScript components. So this is the MetalJas website, and if you scroll down to the bottom, you'll see here that there are two sub-projects that are built. One is Crystal UI, the other one is Steel. And Crystal UI is what she showed yesterday. These are the Alloy components that have been migrated over to MetalJas. And so we'll be developing, our plan is to develop a new JSF component suite built on top of this for support for Liferay 7. Steel UI is for Launchpad, very similar type of component suite for Launchpad. So for Liferay 7, you'll have your choice. You'll be able to develop Alloy components or develop using JSF component tags for Alloy or for Crystal. Now, one of the things I'd like to talk about real quick is versioning. In the Liferay Faces project, we had what we call a multi-module project. And this is very typical. You'll see this in projects that are built with Maven, where you'll have a version element in the POM and then a bunch of modules. Well, this is very convenient. That's the benefit of that. But the drawback is that all your modules have the same version number. And this actually creates a bit of a problem. And my son, Paulie, is quite good with an open source tool called Blender, and I asked him to create this picture for me. So if you consider a team that's running a race, and let's say each of the runners are arm in arm or hand in hand, really the team can only go as fast as the slowest runner. And in the case of Liferay Faces, in this past release we had, that Yoda right there with the lightsaber would have been Liferay Faces Alloy, because that was the jar that got the most power and the most attention, but it was the one that went the slowest. So when you have all the same version numbers on your jars, you have to release them all simultaneously. So we had a decision to make. In order to avoid a long release cycle, on one extreme, the extreme to the right would be to have a separate Git repo for each and every module so that they could be on independent version schedules. Or the other extreme would be where we had kind of a single Git repository with a multi-module project structure. So we reached a compromise. We now have 7 new Git repositories. I recently wrote a blog about this. And this is going to allow us to release all these things on a separate version schedule. So, for example, we'll be able to release a bridge for use with Liferay 7 before Crystal is available. Okay, and we'll be able to time it in different ways. Or if there is a repair that we need to make in the bridge implementation, we can get that out much more quickly. This is the new dependency diagram. This is also available in these slides or in my blog. And we try to, so one of the benefits of doing this, to have these separate Git repositories, is the dependencies became, and the relationships became much more clear. And so I would just commend this diagram to you if you're interested in understanding how we're breaking up these different projects. And this long release cycle that we had here between 2014 and 2015 will be alleviated. We won't suffer this anymore, at least we hope we won't suffer this anymore, because we'll have a new version scheme and we'll be able to release artifacts from these different Git repositories. Brief update on JSF 2.3. This is a JSR that's going to be in Java EE 8. And this is led by Ed Burns and Manfred Ream of Oracle. This was convened in September of last year, and we're not quite at EDR 1 status. If you follow the expert group mailing list, it looks like it's going to be quite soon. Java EE 8 is going to be the first half of 2017, and then normally it's about a year, sometimes 2 years before the application servers are actually supporting it. So this is something we're talking about 2018 before we're seeing this technology. It will have a hard dependency on CDI2 and also Servlet 4. And you can follow this at JSF_spec on Twitter. The main features for JSF 2.3 are going to be support for HTTP2, which is why it has a dependency on Servlet 4. And for those of you that are familiar with JSF, JSF knows what resources the browser is going to ask for next, because that's information that can be found in the JSF component tree. So one of the things that we're thinking about for JSF 2.3 is to take advantage of HTTP2 and just feed all these resources directly to the browser, because we know it's going to be asking for them anyway. There's also a lot of features that are going into the reference implementation, Mohara, CDI producers, to make it possible to inject things like the faces context and so on. You'll be able to decorate factories using alternative producers and so on. Just a lot of CDI-based features. There's another JSR, MVC 1.0, and this is led by Santiago from Oracle and also from Manfred. And this is an action-oriented type of MVC, as opposed to JSF, which is component-oriented, and it's layered on top of JAX-RS. The reference implementation is Ozark, and this will be an alternative to Spring MVC. Now, in order to use it in a portal like Liferay, we would need to write a bridge to make this happen. But this, again, this is future. And finally, we have Servlet 4, which I discussed. The main feature is HTTP2. So that's all we have for today. I wanted to thank you all for coming, and again, thank Scott for taking time out of his busy schedule for coming and showing us the demo of Pluto. Again, I would commend you to help us, if you could, with Pluto, with reviewing the spec, with the TCK. And do we have time for questions? I'm afraid. Okay, well, we're available afterwards if you have any questions. Thank you.
Thank you.
Thank you.